Or this is no. Hello, my name is Khang, joined by Deven Contrilla and Lucas Doe. We all attend Westlake High School and proudly represent the apprentice design team. We'll save all of our questions for the end once all of our presentations are done. Together, we spent the offseason developing skills that would help us not only as individuals but also as contributors to our robotics program. While each of us worked on different areas, I want to focus on what I personally did during the offseason and how it connects directly to FRC. Over the offseason, I focused on preparing for the CSWA, which I plan to take later this year. Instead of treating the offseason as a break, I used it as an opportunity to strengthen my CAD and design skills in a way that would directly benefit our team during the build season. Oh, I don't. Over the My main goal during the off-season was to become more confident and efficient in SolidWorks. Rather than learning features randomly, I focused on the skills that are actually used in FRC. I practiced creating clean extrusions and cuts, proper fillets and patterns. I also spent time modeling parts from drawings and from real-life components. This helped me better understand how designs translate from ideas into real manufacturable parts. This kind of practice mirrors what we do in FRC when we design shooters, intakes, and climbing mechanisms. The off-season gave me time to slow down and truly understand how and why different CAD features work instead of just rushing to finish a design. Is it not shoot? Okay. To prepare for the CSWA, I followed a structured approach so that when I eventually take the exam, it feels familiar rather than overwhelming. First, I reviewed the main CSWA topics such as sketch relations, part modeling, assemblies, and mass properties. I broke these topics into smaller sections, practiced them repeatedly until they felt natural. Okay, press. How do I go back? Is that? Second, I focused heavily on concept sketches, which is a key concept in both CSWA and FRC. It means creating models that are easy to modify later. Instead of locking myself into fixed dimensions, I practice using constraints and relationships so parts could adapt when changes were needed. This is especially important in robotics when designs are constantly changing during testing. Third, I worked on improving both speed and accuracy. Since the CSWA is timed, I practiced modeling efficiently while still maintaining precision. I learned shortcuts and cleaner workflows, which also helps during build season when fast iteration is critical. One of my main goals was to make the CSWA feel easy when I take it. To do this, to do this, sorry. To do this, I practiced beyond the exam level. If the exam required simple parts, I practiced more complex ones. If it included basic assemblies, I built larger assemblies on my own. By pushing myself slightly past the required difficulty, the actual exam becomes much less intimidating. Instead of hoping I know the material, I can be confident that I've done similar tasks before. This same mindset applies to FRC. Preparation reduces stress and increases performance. Everything I worked on during the off-season directly stems from the first robotics competition. FRC requires fast, accurate CAD, strong communication, and designs that can change quickly. Preparing for the CSWA strengthened the exact skills needed for success in FRC. Better CAD skills mean clear designs, fewer manufacturing errors, and faster revisions when something doesn't work. CAD in FRC isn't just about creating parts, it's about solving problems efficiently under pressure. This off-season preparation allows me to contribute more confidently to the team. With stronger CAD skills, I can participate more effectively in design discussions, support newer members learning SolidWorks, and help ensure that parts are ready for manufacturing sooner. Instead of relearning CAD each season, I'm building long-term skills that will benefit the team year after year. In conclusion, I use the offseason to prepare for CSWA by strengthening my SolidWorks fundamentals, improving efficiency, and understanding the application as a whole more. I broke down the exam topics, practiced constantly, uh, and pushed myself beyond the minimum requirements so that when I take the exam, it will feel manageable. Most importantly, this preparation directly stems from FRC. The skills developed through CSWA preparation are the same skills required during build season. Clear CAD, fast iteration, and adaptable designs. By using the off-season productively, I've positioned myself to contribute more effectively to the apprentice design team and to our overall success in future competitions. Okay, I'm done with my slides. Next we have Devin Controlla talking about sustainability and environmental consultations.
Hi everyone, my name is Devin, and I'm going to be talking about my interest in sustainability and how FRC and robotics has helped me learn the skills I need for my personal project and how I plan on extending this through our program. So, my interest for sustainability started when I realized I wanted to create and learn about ways to preserve our Earth for our generation and future generations. And so my blog, greenperspectives.blog, was the first thing I started doing to put myself out there and start learning and teaching more people about this. And so on this blog, I explore sustainable investing, renewable energy, and current events revolving around sustainable energy and innovation in the industry. And so up on the screen, I have some of my favorite posts. On the top left, my most recent post is about Flint Hills Resources and how they lead solar integration in the oil industry. And the bottom two posts are Tesla's robotaxi and self-delivery and Waymo and uh, how they're changing the industry of rideshare through electric vehicles. And then on the top right, I have the top three countries that run on almost 100% renewable energy, which is more geared towards like renewable energy around the world and current events. Um, so more about the uh, Flint Hills resources. Their largest project is in Corpus Christi, Texas, and they have around 57,000 solar panels across 100 acres of land. And this solar farm is directly adjacent to the Corpus Christi West refinery. And this is significant to the refinery because this solar farm is able to generate up to 28% of all of the refinery's power needs. And so this hybrid approach allows for increased efficiency and reduced operating costs. So increasing the business of the oil refinery. But more than that, it allows the refinery to reduce their emissions and reduce their carbon footprint, which is better for the world. In addition to writing blog posts, I also interview leaders in the industry. So my first interview was with an energy attorney in Austin, and he taught me a lot about uh, the legal side of renewable energy and walked me through some of the business deals that he's been a part of between larger companies revolving around renewable energy. My second interview was with the vice president of stadium operations at Q2 Stadium, home of Austin FC. And so he taught me a lot about the LEED and TRUE certifications that Q2 has. And the LEED certification is a global certification that's awarded to uh, buildings that were built sustainably and with certain certain features in mind, such as waste management and uh, water conservancy, and a lot of other ideas in mind. And the True certification is something that Q2 really focuses on more currently, and that is reaching a certain threshold of recycling and waste management um, to obtain that true certification. My most recent interview was with a professor at the UT Energy Institute, And we talked a lot about where renewable energy and economics meet, so that halfway point. And then I also learned about some of the paradoxes and lessons that a UT student would learn in his classroom. So, leading into my FRC experience and how that helped me with my personal project, uh, this semester, as a designer, we learned a lot about SolidWorks and we spent a lot of time CADing and learning how to use the program and improving our skills. And the first project we did was a gearbox, and the skills that we learned were systems thinking. So comparing gear ratios and how that affected torque and what the output that we needed. Another project was the full robot CAD. So we split into groups and each built our own mechanism. And that taught us how to design under constraint because we only had a certain amount of space in the robot to build our mechanism. And so that was really valuable for learning how to design under restrictions. And then in between those two projects, we did rapid prototyping for shooters. And this taught us the values of reliability and simplicity. And all of these projects were for past FRC games. And so we have a lot of experience for the season now. How this translates to my personal project. So my personal project is an automated mechanical recycling separation bin, and it separates objects based off their material. So currently, in the US, over around $3.5 billion are being used for the cost of sorting labor at recycling plants. And this is after it's already gone through machines. So my goal was to it was to improve that. My goal was to improve that the my goal was to improve that process. And so through the skills that we learned, systems thinking, designing under constraint, and reliability and simplicity, these all relate to my project. So I have a drawing of the system on the right. And so systems thinking helped me a lot because there was a lot of different variables that led to the success of the separation. So there was a lot going into the slope of the actual ramp. And so the mechanism works through a trapdoor system by separating glass from other materials. And that's the first part of the separation process. And so part of that is through a trapdoor and friction and the weight sensors of the trapdoor was the main part of um, how successful my sorting process was. And designing under constraint was a big part of it because the design is supposed to fit into residential recycling bins. So I only had so much space to work with. And then for reliability and simplicity, uh, having more simpler mechanics reduced failure points, especially in early phases of building this machine. So how I'm hoping to translate sustainability into the Westlake robotics program. Um, so we have this robot called the CanBot, which is an interactive robot designed to collect and crush aluminum cans. And a member of our team last year was awarded a grant for $5,000 from Novelis and Ball. And so this was a collaboration between the two companies, and they awarded this $5,000 grant. And Novelis is a global leader in the aluminum and rolling and recycling. And Ball Corporation is a major global manufacturer, and they especially work with aluminum beverage cans. So last year at States, we brought the CanBot, and in efforts to increase the amount of cans that we were able to crush, we came up with a raffle. And so, and with this raffle, other teams would bring us their aluminum cans to be entered in a raffle to win a signed coral and algae that was signed by every team at the state's competition. And uh, After the competition, we had collected 500 cans and they were crushed all by the end of states. And we tried this again at World Champs, but we weren't as successful because at World Champs, they were selling more plastic bottles and plastic sodas, so there wasn't as much aluminum to sell. Next, we're going to be hearing from Lucas about his efforts in his personal project, his
Good morning, guys. My name is Lucas, and I will be talking about how SolidWorks and FIRST has expanded my horizons. So first off, SolidWorks. SolidWorks is the baseline of everything you do in engineering. And when I first started FRC, that was the first thing I learned as a designer. Seniors from last year to really helped me to learn the CADs, and that really helped me long term till now too with all my projects with related to engineering. So first things first, last year, Reefscape 2025. Last year, this was my first project. It was the funnel design, and we had every bot, and it only scored L1, and we wanted a faster design for the Everbot. And me and another partner of mine came up with the funnel design. The funnel design just basically makes faster cycles from feeder to reef by allowing the Everbot to not turn around, which reduces time. But there were some caveats to how our process were doing. Our flawed processes was what the rush prototyping. We rushed the prototyping really fast. We had one phase of cardboard, and then we didn't look at the data or how it was effective, and we just went straight to building with acrylic and CNC machines. And we didn't have any feedbacks from our mentors. We didn't have feedback from our coaches, so that was also bad. And then about the actual designing component of it, we had we waited too long to design it. There were I made too many changes and redesigns to the CAD, and that was really detrimental to our whole mechanism. The funnel was unreliable. We didn't have enough planning for it. And lastly, the faulty results were there was no good results. We never had promising results from it. And the goal was to finish before state, and we did not finish it before state. So timing and planning is the most important thing here. And yeah, the coral was intaked only 30% of the time, 35% of the time. And there's just a point where you know when to stop working on a mechanism when it just does not work anymore. Next up, this and with all of the lessons that I've learned from my actual season last year, I planned on making the solar panel project. The solar panel is a sun tracking solar panel with two rotational axes. It's an ongoing project, but it's going out really good right now. Most of the materials are provided by the team, and the panels are honeycomb shaped because I thought it looked cool, and it's angled a little bit inside to make like a small little sphere. But the main issues that I found, or the things I found hard to make, was firstly the worm gearbox. For the actual axis that turns the solar panel up vertically up and down, the panel has to hold that angle for a long time since it's pointing at the sun. And with like a normal gearbox, uh the motor wouldn't be able to handle the stress and the strain of it. So with a worm gearbox, the worm gearbox does not allow backtrack. So it can just stay there for as long as it wants without the motor having any damage to it. The second one is large diameter gears for the base rotation, but and I couldn't find any large diameter gears online, so I had to make one myself, and I it resulted into a 3D printed gear, and it worked out great. A lot of my and the 3D printing relates to material prepping. There was not a lot of low costing stuff online, so I had to 3D print a lot of that, and it really helped with the 3D printing. FRC's impact was a lot for me, and it taught me so much in a year. It taught me how you need to communicate with your teachers, your mentors, to have a great project, a great result to it. And CADing and manufacturing is not the most important parts of this. It's the planning and the direction that you go in. You need to have clear direction. You have to have really precise planning to have a good conclusion to this. And results, if you don't see like going results along the way of your project, then it's a sign that it's just not worth it to do it anymore. And yeah, that is it. Thank you. And I already did. Is there any questions?
I have a question.
Yeah, what's
If
up?
you
What's
had
up, Chris?
if you had more time to work on your mechanism, like the um for the upgrade thing, like the ramp, what is one thing that you would improve if you had like more time to work on it?
Um, I think we just I there was nothing that we could improve on it. It was just a fault. It was just a faulty design from the beginning. That's why I said like there's just to a point where you just have to like abandon the mechanism entirely. So I think we should have in the prototyping phase we should have made more data, made more conclusions to it to see how effective it was first. Did it answer your question?
Yeah. What about you, Devin? What's one thing that you would improve on?
Can you repeat the question, please?
What's one thing that you would improve on if you had more time to work on like your project?
Um, if I had more time to work on my project, I would do a couple things. I think a concept sketch would be really helpful because that was something that we learned was a really important part of the process. But I felt like with the deadline, it was better to just start building and experimenting with that. But I think a concept sketch definitely would have been helpful. I also would have tried to plan out more systems for filtering more materials because right now um, my my mechanism, the trapdoor, it's mostly to separate higher weight objects. So that would mostly be glass if you're working with bottles and cans. And so something that I'm hoping to do in the future is maybe filter aluminum from plastic as well. Also, after that first filtering of glass from everything else. So I wish I spent more time planning out more uh, separate means of separation of all the objects.
Cool.
Right. And do you have any more questions, or is that it?
No, I think the meeting was pretty good. Kind of answered all
All
my
right.
questions.
Okay. So thank you for joining by and listening to our presentation. Wait, how do I end this? Stop record.